Hey everyone, it's Leni. Welcome back to the channel. Today we have a video coming to us from Debunked, and this is, can you really be sucked out into space? That sounds terrifying. I don't ever want that to happen. Let's find out if this is a myth or if it's reality. Make sure to go show Debunked some love on YouTube.
We've all seen it in the movies. One small crack in a spacecraft's hull or window, the air
Yes.
screams, and an
Everything
ill-fated
gets sucked
individual
out.
is squeezed
I mean,
through
we
the
even
hole
see it on
and out
airplanes,
into the
right?
void of space as some sort of meat slug.
Ugh.
If it's an airlock, forget it. Everyone in the
everything's
vicinity is getting blasted into space like champagne corks. But
Yeah.
would any of this really happen? Let's explore the physics of this classic movie trope and the
Let's
time it
do
happened
it.
for real on the ISS.
Oh.
I'm Stu, and welcome to Debunked.
So, you're going about your average working day when suddenly the protagonist of your particular narrative bursts in being chased by generic
no.
space soldiers who discharge their weapons with the accuracy of a headless stormtrooper. One of the
Okay.
stray projectiles
Why
pierces
did the red
hull.
guys have bellies?
What
This is funny.
happens?
Oh gosh.
Despite what you see in science fiction
Alien
movies,
resurrection.
this
Space
is far
truckers.
from factual physics.
Cloverfield paradox.
To get
I need
a
to see
real
some more
understanding
movies.
of the fluid dynamics at play here, we need to explain how decompression works.
First, what do we mean by a pressurized cabin? Here on the Earth's surface, we humans, and all other terrestrial organisms while we're at it, are used to the atmosphere bearing down on us, thanks
Okay.
to gravity's pull.
Yes.
What we're talking about here is the actual cumulative weight
keeps
of
our
the
feet
air
on the ground,
molecules, from the edge
basically.
of the atmosphere all the way down to the Earth's surface. Weight is a force, and the force acting on each unit of area is what we call pressure. For convenience, we use a unit of pressure called atmospheres, where the pressure at sea level is equal to 1 atmosphere, about
Oh.
14.7 pounds per square inch, or 101,325 pascals. Nope,
Nah.
not that guy.
Look at
It's
Pedro.
important to note that
Pedro.
while the weight of the air is acting downwards at any given height, the pressure pushes in all directions. Left, right, up, down, etc.
Okay.
Because our bodies have evolved to function under these conditions, very low or very high pressure scenarios are, shall we say, not
Ugh.
conducive to survival.
Okay.
To ensure that our lungs, eyes, and the water in our tissues all continue to behave as normal, we can pump air into the cabin of a spacecraft until the internal pressure equals
this the
roughly
same?
1 atmosphere.
Okay.
When we do this, we say the cabin is pressurized.
Pressurized.
In contrast
Oh,
to
so that's
conditions
what
at the
they
Earth's
do on
surface
airplanes
or
too.
inside a pressurized cabin, the vast majority of outer space is a vacuum.
This means it's almost totally devoid of matter. And
Oh,
no
okay. This
matter
is making me feel
means no
nervous about
pressure.
flying again.
What we're dealing with
I don't
then
like this
is
type
a
of
scenario in which we have a cabin filled with air at pressure of roughly 1 atmosphere set
Okay.
against the background of the vast coldness of space, which is pretty damn close to 0 atmospheres.
Okay.
So, what happens if we breach the hull so that there's a hole in the barrier between the 1 atmosphere conditions and
Everything's
the 0
gonna get
atmosphere conditions?
Pulled out or
But
escape,
before
right?
we find out the true physics of this scenario, we are meticulous about cutting through all the noise of myths and misconceptions to present you with fact-based content. That's why we're working with today's sponsor, Straight Arrow News, because they apply this same approach to journalism, helping you
Reporting Debunked, you're finding a trustworthy way to get the news. Let's get back to space.
So, if there is a human-sized hull breach, what happens when the 1 atmosphere conditions and the 0 atmosphere conditions
I'm thinking
are
the
exposed
atmosphere is going
one
to
another? The difference in
leak
pressure
out.
between the two volumes gives rise to what we call a pressure gradient force. And this
Pressure
force
gradient
drives
force.
the air from the high pressure region, the cabin, towards the low pressure
lower.
region,
Okay.
space.
So
if we had
basically what
connected
we-
two
what I
cabins,
said.
one with a slightly higher pressure than the other, the flow would continue until the air pressure in
And they
both
would be
cabins
equal?
equalized.
Okay.
In our scenario, though, equalization obviously
not-
can't occur.
no,
A
'cause
rush of
space is
air from
massive.
our humble cabin isn't going to pressurize the vacuum of space.
So, what happens then? The air keeps moving out.
Until there's nothing
either
left.
somebody plugs a hole or there's no more air left in the cabin.
So, how quick and or violent is this decompression?
Let's first imagine we're in an average-sized cabin. something like a compartment on the International Space Station, and we have a tiny hole.
A tiny
Would
hole.
you be sucked through it?
No.
No.
And you'd have rather a long time to do something about it.
In fact, a real-life example of this scenario unfolded on the International Space
No
Station.
way. When did this
In
happen?
2018, the ISS was
2018?
found to be losing pressure. The leak was traced to the docked Suez MS-09 spacecraft, where a
What?
2mm or 0.08-inch hole about the width of a
How?
matchstick was discovered.
The width
And how
of a
did the astronauts
matchstick.
handle it? Was anyone pulled dramatically or even noticeably towards the opening? No. Instead, to momentarily stop the leak,
Look at
astronaut
them.
Alexander
They're so
Gerst
cool.
is said to have simply plugged the hole with his finger until they could temporarily
look
patch it
how
up
tiny
using tape
it is.
and gauze. This comment from NASA Ground Control was recorded on an ISS live feed.
Let's
Right
hear
now,
it.
Alex has got his finger on that hole, and I don't think that's the best remedy for it.
Not
Was
long
he putting
term,
himself
no.
at risk? Could his finger have been pulled through the hole as the pressure continued trying to reach equilibrium? We can calculate the force at the hole by taking the difference between the inside pressure and the outside pressure
I bet his
values,
finger
and
looked
then
weird.
multiplying them by the cross-sectional area of the hole. This would give a pressure difference of about 0.32 newtons, which works out to a force that's roughly equivalent to the weight on Earth of 3/4 of a golf ball.
Oh
That's
my gosh,
hardly
okay,
going
it's
to rip
fine.
your arm off.
It's fine.
According to figures calculated by the NASA Space Flight News Agency,
The leak rate, as it stood, would have meant they would have run out of air in 18 days.
18 days.
Which
okay.
may sound fairly dramatic,
No, but a lot of
was
time
more
to
a figure
fix
to
it.
illustrate just how small the leak was.
Yeah.
So, if you find a small hole in your spaceship, a good rule of thumb is
Put your thumb on
use
it.
your thumb.
but what if the hole isn't
Was way bigger?
thumb-sized? What if the
Yeah.
whole door goes? That brings us to Hollywood's favourite method of ejecting
Moonraker.
undesirables into outer
79.
space, the airlock
Oh,
blowout.
no. Okay, there's a lot of movies that it happens.
There is a moment.
Oh, that's a good one. Interstellar. Space Odyssey. Okay, there's so many movies I have not watched. Oh, Men in Black, definitely seen that one.
In this scenario, we usually find our hero somehow outwitting or overpowering their respective combatant, whereby said opponent is shoved into an airlock and promptly fired into space by our hero, releasing the outer door. Alternatively, a human-sized hull breach may have occurred, exposing the pressurized cabin to the vacuum of space. In either situation, the room is usually of small to medium size, and the
Yeah.
opening is a lot bigger than our previous digit-sized breach.
Yes.
So could this ratio see someone expelled into space faster than a greased puffer pig? A chamber of about 30 meters cubed with a 1 meter square door, when pressurized at roughly 1 atmosphere, would see the pressure drop
Quickly.
to 10% in a fraction of a second.
Holy
The continuous,
crap.
extreme suction you see in science fiction films is just that. Fiction.
And the suction force, from a physics point of view, is sort of a myth.
When the airlock is opened, any air between you and the inner door rushes towards the open hatch, from the high
Okay.
pressure region to
To the
the low
lower.
pressure region, as we described earlier. The resulting force that moves you towards the airlock isn't continuous suction from the vacuum of space. It's ordinary aerodynamic drag. Air particles colliding with your
Okay.
body, exactly like what you would experience on a windy day. Drag
Wow.
force is given by this
Oh my
equation.
gosh, look at that equation.
Without getting too deep into the maths,
I don't wanna
this
even see that.
shows that the size of the force depends on the velocity of the airflow squared. Space scientists at the University of Leicester, who ran the numbers for the type of airlock scenario you see in the movies, estimated that partway into the airlock, you might be looking at a force of the order of a few hundred newtons.
Okay.
The study concluded
The person would likely get knocked off their feet. However, once they are on the ground, their cross-section will drop to roughly a sixth of when they were upright, and their
Okay.
drag coefficient will also
Just
drop.
past-
So the
okay.
force will fall to approximately a tenth, and the person would not get dragged into space.
Okay.
An important aside here is that they were investigating the same trope as us, and like the vast majority of sci-fi
So
movies,
it's not like a
they're
vacuum that's
presumably
gonna just
including
suck you out.
Some sort of artificial gravity.
Okay.
The very idea of being knocked off your feet depends on it.
in more lifelike zero-G conditions, the force would be the same, but you'd be shoved directly towards the opening rather than falling over. What about if you were right at the opening? The airflow here is considerably faster. It can't go faster than about the speed of sound at cabin temperature, but
Okay.
we're still potentially looking at a sufficiently high speed to generate a drag force of the order of several thousand newtons.
Okay.
In this scenario, you would be hit by a force roughly equivalent to several grown adults at
Ooh.
Earth's surface.
Okay.
Although this push would only last a fraction of a second as the pressure collapses, it would probably be too much to withstand, even if you have a grip on a solid handhold. If you were tethered, you should
Oh.
be alright. Not the dramatic and sustained mega suction you've seen in the movies, though.
Okay, so it's a
if
little
the airlock
dramatic
doesn't
in the
rise to
movies.
task, then how about a large cargo hold with a whopping great set of hydraulic doors?
Mandalorian.
In the cargo control area.
Hey Brian, check it out. Meg's poking around the cargo hold. I'm gonna give her a little scare.
No. Yeah. Oops.
Surely this ratio will give us the big blockbuster blowout we're looking for. Bigger volume, bigger problem, right?
The initial rush would indeed be fierce, but the overall story isn't hugely different from the
Okay,
airlock
basically the
scenario.
same.
When the pressurized space is open to the vacuum, the air rushes out. At the very lip of the doors, the flow is fastest, up to about the speed of sound. Since we have more air and a larger door, we do have a greater mass flow, a
Okay.
greater barrage of air particles battering anything in the line of sight of the opening. But the blast would still only last for a brief moment.
Okay.
Again, if you're right near the lip, you're going to be shoved out.
Yeah.
If you're mid-bay, you could be shoved
Maybe
out.
just knocked
The
over.
space scientists at Leicester thought about a big door scenario too.
If the size of the door was increased by a factor of 4, so that the hole is 2 meters by 4 meters, the force would increase by a factor of 16. This leads to
Okay.
a force, when the person is flat on the ground, of around 500 newtons, which means they will be dragged out if the coefficient of friction between them and the ground is less than around 0.7, which is reasonable.
Here, in the cargo
Oh,
bay though,
okay.
the real killer might be debris. A crate, a
Oh,
wrench,
yeah.
or even a loose panel would hit a
Get
lot
hit in the
harder
face with a
than air.
box.
If you survive the impact, your spacesuit
Big old
probably
crate.
wouldn't. And if your spacesuit is compromised in a depressurized
you're
cargo
done.
bay, it's game over.
You're done. Okay, well, there you have it. Can you really be sucked out into space? Apparently, yes, but not so dramatically as the movies show. So make sure to go show Debunked some love. And if you like this content, don't forget to like and subscribe. I'll see you guys in the next one.